In today's video, we'll be deriving the quadratic equation by a completing square method. So first of all, we know that the general formula for a quadratic equation is of the form ax squared plus bx plus c equal to 0. So to derive the quadratic equation, there are two things we need to have in mind. The first thing is the coefficient of x squared should be unity. By unity, I mean that the coefficient of x squared should be 1 and the constant term should be on the right hand side. So we are going to start by dividing all through by a. So we are going to have ax squared divided by a plus b divided by a x plus c divided by a equal to 0. It's 0 because 0 divided by any number will give us 0. So a can go away. We'll be left with x squared here. X squared plus b on a x. B on ax plus c on a. So now here, in order to send the constant term to the right, there are two things we need to do here. We can either subtract minus c on a on both sides, or we simply carry it over the equal to sign, noting that the sign of the constant term c on a will change since it has crossed the inequality sign. So doing that, we're going to have x squared plus b on ax to give us minus c on a. So now the next step, we need to add half the equation of x squared on both sides. So the next step, we are going to add half the equation of x, all that squared on both sides of the equation. So I'm going to explain this step with an example. So the next thing is x squared plus b on a x plus half the coefficient of x. The coefficient of x here should be b on a, and now all that squared. Remember that with equal to sign, if we don't want to change the equation, we need to do whatever we do on the right hand side, we should do it on the left hand side. So plus half the coefficient of x, b on a, all that squared. So now I'm going to explain the reason why I took half the equation of x all that squared on both sides by expanding this function a plus b all that squared. If we expand this function, this can be written as a plus b times a plus b times a plus b times a plus b, and this will give us a squared plus 2ab plus b squared. So let's expand this a plus b on 2 all that squared. Now we are going to have a squared plus ab plus b squared. So what we're trying to do is to look for an expression on the left hand side such that this one should be a perfect square. So we want this to be a perfect square. That is why we need to, if we compare this, so if we can express this function on the left hand side like something of this form, then we can say, okay, this will be equal to this, or this will be equal to that form. So if we do that correctly, you'll notice that the form will be of the form x plus b on 2a. Now all that squared. So if you are not sure of it, you can simply expand this function. You notice that it's going to give us this one, because expanding this we are going to get x squared plus 2 times this, which is simply going to give us b on ax, plus now the square root of this, which will give us that. So if we continue our simplification, we have minus c on a plus, expanding that, we are going to get b squared all over 4a squared. So now if we continue with this, like if this one comes here, if we continue there, so we're going to have so x plus b on 2a all that squared to be equal to minus, so now I have to look for the LCM, plus b squared all over 4a squared. So the LCM here should be 4a squared. The reason being that in 4a squared, a can be gotten from 4a squared. So 4a divided by a is going to give us 4a. 4a times c is going to give us minus 4ac plus 4a squared divided by a squared. 4a squared will give us 1 times b squared will just give us b squared. So we have to rearrange the function. So we are going to have x plus b all over 2a, now all that squared to give us b squared minus 4ac all over 4a all that squared. So now to remove the square root, a squared sign, we take squared on both sides. So we're simply going to take the squared on both sides, the square on both sides, square root on both sides. So the square root will go with the square will go with the square root sign, and now this function will be equivalent to the square root of b squared minus 4ac all over. Now 4a squared can be written, 4a squared, this 4a squared can be written as 2a all that squared. So if this can be written of that form, therefore our new 4a squared will be of the form 2a, now all that squared, and now the square root, which will simply cancel. So we'll be left with x plus b on 2a to be equal to the square root of b squared minus 4ac all over 2a. So the next step we need to do is to transfer this constant term to the right hand side, and doing that the sign is going to change. So we're going to have x now to be equal to, now we should notice that the square root sign will give us plus or minus a value. So this will just give us minus b all over 2a plus or minus the square root of b squared minus 4ac all over 2a. So here we look for the LCM. The LCM will be 2a, which is the lowest common multiple. So here the LCM will be 2a. 2a divided by 2a will just give us 1. So 1 times minus b will give us minus b plus or minus. I think someone should now be familiar with this. So 2a divided by 2a is going to give us 1. Now 1 times everything up here will give us b squared minus 4ac. So if you look at it very well, you'll be able to recognize that this is the quadratic formula, which is of the form x equal to minus b plus or minus the square root of b squared minus 4 ac all over 2a. So this is the quadratic formula. Okay, thank you guys for watching. Please, you can leave in the comment section which topic or any question you want me to make a video on. I'll be very happy to do that. Thank you.